Hey everybody, welcome back. Let's talk about section 9, rational functions with vertical asymptotes. So we've been talking about vertical asymptotes, but we have some new notation that I want you to see. So we can see in example 1, we see these invisible vertical asymptotes, and we know that they exist because the graph avoids these two areas. So we can see that they happen at x equals -5 and x equals +2. But as you can see, depending on which way you look at the graph, as we go from the left to what's happening at x equals -5, the graph goes all the way down to -infinity. But if I look up here, as I look at what's happening on the right side of x equals -5, the graph is doing something completely different. So how can we talk about what's happening around that asymptote at x equals -5? So let's talk about that. So we know that x equals -5 and 2 are those vertical asymptotes. So this limit notation regarding a vertical asymptote says this. We say as the limit that x approaches -5, this little thing here is a negative, and that means we read this as from the left. And as we see it here, we read this from the right. So it's still this value of -5, but we read this as it's approaching from the left. F of x equals what? So as I go to this asymptote from the left side, what is y doing? Y is getting lower and lower and lower. So we say this is going to -infinity. What's happening as we approach -5 from the right side? So we see as we do this, y is approaching +infinity. So we say it this way. So in words, as x approaches -5 from the left, f of x approaches -infinity. Also, as x approaches -5 from the right, this notation here, f of x approaches +infinity. Okay, so we're looking on either side of the vertical asymptote here. Secondly, for example number 2, again, remember first factored form first. Let's factor this. This is a difference of 2 squares, x plus 3, x minus 3. In the denominator, we also have a difference of 2 squares, x plus 2 and x minus 2. We see here that there are some vertical asymptotes, and we see them here in the denominator where x is at -2 and +2 for those vertical asymptotes. So if we were looking at that, I would say, okay, there's a vertical asymptote here at -2, a vertical asymptote here at +2. So the limit as x approaches -2 from the left, what is g of x doing? We'll answer that in a minute. And the limit as x approaches -2 from the right, what is g of x doing? We also see here at 2 and +2 that the limit as x approaches 2 from the left and the limit as x approaches 2 from the right. Let's figure out what g of x is doing. So if I sketch this on my calculator, so let's just pull up our calculators really quick. Okay, so if I look here and I plug in my calculator at y equals, and I type in x squared minus 9 divided by x squared minus 4, and I graph it. You see where that graph is? Oh, that's an interesting thing. I don't know how to make that one go away. That's okay. So this graph looks like this. I'm kind of just going to copy and emulate what we see here. Okay. Looks something like this. So once I see that graph, let's talk about what's happening on the left side of it. So here's -2. What's happening on the left side? We can see that it's going downwards. So it's going to -infinity. What's happening on the right side of that? It's going up to the +infinity. What's happening on the right side of +2? It's also going up to +infinity. And what's happening on the on the right side of that +2, it's going also down to -infinity. So how can we tell where there's a vertical asymptote? This is very similar to what we've seen before, where we're talking about the numerator function over the denominator function. As long as it has no factors, aka holes, that the vertical asymptotes happen where the zeros are of d of x, or setting the denominator equal to 0. Okay, so numerically, what would that look like? Let's talk about it. So if I'm looking at this, remember, again, factored form first. Let's factor g of x. If I take out an x here, we get x plus 3. So we've got x times x plus 3 all over x minus 2. Okay, so let's plug that into our calculator. Let's pull that, let's pull that back up. Here we go. Here we go. All right, let's look at a y equals. And we're going to clear that out. So we end up with parentheses x squared plus 4x minus 12. I want this thing to go away. I've never seen that one before. This little bit. Anyway, divided by parentheses x minus 2 squared. Okay, that's what it looks like. Let's graph it. Okay, and actually before we can graph it, let's look to see what's going on here. Remember that we're going to change our table set, so go to table set. We're going to have it changed to ask, because I want to see what's going on the left and right. So let's plug in some of those values. So let's do 1.9, 1.99. I really need this thing to go away. Here we go. 1.999. Okay, so let's finish filling in this chart. So at 1.9, let's zoom this in, it's negative 93.1. At 1.99, it's negative 993. At 1.999, it's negative 9993. And then 99993. So what do we see is happening? Every time we get bigger or closer to 2, we get closer and closer to negative infinity. And as x goes to 2.1, we see it's at 107.1, and then 1,007, and then 10,007, and then 100,007. So as x gets closer and closer to 2 from the right side, g of x is going closer and closer to positive infinity. So let's talk about what that looks like. So remember, the limit as x approaches 2, this would be from the left side, so we use this notation. G of x is going to negative infinity. And for this one, the limit as x approaches 2 from the right side, g of x is going to positive infinity. And if I wanted to show you what this looks like, it looks something like this, where 2 is that vertical asymptote. We see something like this. So we see from the left side, it's going to negative infinity, and from the right side, it's going to positive infinity. All right, example number 4. Again, let's find your factored form first. So what multiplies to negative 12 and adds to 4? We've got 6 and negative 2. And in the denominator here, we've got x minus 2 times x minus 2. So right off the bat, I know for sure there's a hole here because they're common factors. So there's a hole at x equals 2. That also means that the domain, we still set the whole denominator equal to 0. So x minus 2 squared equals 0, which gives us just x equals 2. Is not part of the domain, so we say from negative infinity to negative 2, and then from negative 2 to infinity. We also know that the vertical asymptote and the domain go together, so we know x equals 2 for our vertical asymptote. And even though it's a hole, it can also be a vertical asymptote because it's still left over. Okay? We also have zeros where we set the numerator equal to 0, so x plus 6 equals to 0, so then x equals negative 6. Limit notation of the vertical asymptote. Since our vertical asymptote is at 2, we say what's the limit as x approaches 2 from the left, and what's the limit as x approaches 2 from the right of h of x. And if I sketch this, I'm going to see, okay, well, we've got this horizontal asymptote, and we see it looks like this and like this. Okay, so if I look here, from the left, it's going down to negative infinity. And from the right, it's going up to positive infinity. For the horizontal asymptotes, we still compare the degrees. This is x squared over x to the 2, so it's x squared over x squared. That gives me the co-leading coefficients of y equals 1. And the end behavior, remember, always follows a horizontal asymptote, so the end behavior, the limit as x approaches negative infinity, h of x equals 1. And the limit as x approaches positive infinity, h of x also approaches the horizontal asymptote of 1. All right, that's it. See you in class.